Hello, grade 8. This is Mrs. Lopez, and today we are working on our lesson 4, numbers raised to the 0th power. Before we get started, we are going to again do a quick review on what we've learned so far. So 3 to the 4th times 3 to the 2nd is the same as I would multiply 3 by itself 4 plus 2 times, right? So I will have 3 to the power of 4 plus 2, and that is 3 to the 6th power. And again, if I were to rewrite it, I will have 3 multiplied by itself 4 times, multiplied by 3 multiplied by itself 2 times. So I will have 3 multiplied by itself 6 times. Okay, our next one is 3 to the 10th divided by 3 to the 4th. When I have my 3's written out 10 times multiplied by itself, and I'm dividing it by 3 multiplied by itself 4 times, I can simplify my pairs of 1, and I will get 3 to the power of 10 minus 4, and that is 3 to the 6th power. Okay, next one is 5 to the 2nd raised to the 7th power. 5 to the 2nd is 5 times 5, and I'm multiplying that by itself 7 times. That makes it 5 to the power of 2 times 7, which is 5 to the 14th power. Next one, 4 to the 2nd times 8 to the 7th raised to the power of 3. What that is 4 taken by itself 2 times, multiplied by itself 3 times, and 8 taken by itself 7 times, multiplied by itself 3 times. So that will be 4 to the power of 2 times 3, 8 to the power of 7 times 3. And that is 4 to the 6th, 8 to the 21st. And last one that we worked on is 6 seventh to the 5th power. That means 6 to the 5th over 7 to the 5th. Okay, now let's explore what that 0th power is from our lesson 4. From elementary school, we know that 8 times 1 equals 8, right? So when we multiply a number by itself, when we multiply a number by 1, that equals that same number. If I have 3 times 25 25th, 25 25th is also a 1, right? And that was also going to be the number itself. In this case, it's a 3. What if I change this 25 25th and wrote it in exponential form? I will have 3 times 5 to the 2nd over 5 to the 2nd, right? 5 to the 2nd over 5 to the 2nd. It's still the same one whole, right? Still 25 25th, and that is a 3. According to our rule, taken from here, our second rule is when I have the same base um, and the number is divided, I'm going to subtract the exponents, right? So I can rewrite that part as 3 times 5 to the power of 2 minus 2. Isn't that true? So I had 25 25th. It was the same as 5 to the 2nd over 5 to the 2nd. And then I'm going to simplify that by subtracting the powers, 2 minus 2. And that is still 3 by itself, right? I didn't change anything. I'm just rewriting these numbers. So think about that for a second and let's go simplify some more here. 2 to the 4th divided by 2 to the 4th. 2 to the 4th is 16 divided by 16. Isn't it one whole? 16 16th, right? But according to our rule, 2 to the 4th divided by 2 to the 4th is the same as 2 to the power of 4 minus 4. And that is 2 to the 0th power. Doesn't it mean that 2 to the 0th is one whole? Right? Here I have 4 to the 8th divided by 4 to the 8th, which is 4 to the power of 8 minus 8, which is 4 to the 0th. But isn't a number over itself is one whole? Okay, so 4 to the 0th is one whole. Here in my previous example, we discovered that a number is multiplied by a different number and it equals number itself. But from elementary school, we know that a number times 1 equals the number itself. That means that all of these are a representation of one whole. So 3 times 5 to the 0th is 3, and that makes it 5 to the 0th, one whole. If I'm looking at all of these examples, I can conclude that any number to the 0th power is one whole. Any number, here's my rule, any number to the 0th power is one whole. So again, it doesn't matter what number I'm going to raise to a power. If I'm dividing it by itself, it is going to be one whole. And according to our second rule, when I'm dividing numbers with the same base, I'm going to subtract the exponents, leading to the exponent of a 0, right? And that is still a number itself. So that is still one whole, sorry. So let's go ahead and see how it is related to everything that we are going to do today. Okay, what are the applications? Let's write the expanded form of 8,374 using exponential notation. Before I use the exponential notation, because it's very hard to do, we are going to rewrite it using standard notation. Okay, so I'm going to rewrite 8,374 as in elementary school, 8,000 plus 300 plus 70 plus 4. Okay. I'm going to change that 8,000 now into 8 times 1,000. And I'm going to change 300 into 3 times 100. I'm going to change 70 into 7 times 10. Okay, and I'm going to change my 4 into 4 times 1. This is our place value, isn't it? 8,374. Okay, 1,000's place, 100's place, 10's place, 1's place. Now let's change our 1,000 and 100 and 10 and 1 into exponential form. I want to change all of these into a number with a base of 10. Okay, written in exponential form. From our previous lessons, we know that I can take that 1,000 and I can divide it by 10. So I can rewrite it as 10 times 100, right? 10 is the base that I want. 100 is not the base that I want. I will continue dividing, and 100 is 10 times 10. So I can rewrite my 1,000 as 10 to the third power. So I have 8 times 10 to the third. Then I will write plus 100 is 10 to the second. So I'm going to rewrite this as 3 times 10 to the second. Then I will write plus 10 is a number written by itself, so it's to the first power. 7 times 10 to the first plus 4 and 1. If you look at the pattern here, 3, 2, 1, 1 is 10 to the 0th times 10 to the 0th. Okay, so this is one application of writing a number using a 1 as a number written to the 0th power. Okay, so instead of all of this, I can just use that. And that's what they're asking us to do. Write 8,374 using exponential notation. That is what it is. Okay, 8 times 10 to the third plus 3 times 10 to the second plus 7 times 10 to the first plus 4 times 10 to the zeroth. Okay, let's go ahead and try it on a more complicated number. We have 6,985,062, right? I can even write it out. So 6,985,062. Okay, so how can I write it in exponential notation? 6 million. 6 and the million is 10 to multiplied by itself 6 times, right? So 10 to the 6th. I'm going to write 6 times 10 to the 6th. 900 is my next number. It's 100,000s place. So plus 9 times 10 to the 5th. 100,000s has 5 zeros, so that's how we know that 10 is multiplied by itself 5 times. Next one is 80, and this is 80,000, means that it has 4 zeros, means 10 multiplied by itself 4 times. So plus 8 times 10 to the 4th. See the pattern? 6, 5, 4. Next one, plus my number next is 5,000. 5,000 is again 5 multiplied by 10 to the third power, because 1,000 is 10 multiplied by itself 3 times. Plus, then I have 62, right? I don't have to worry about the zero. Or I can write 0 times, it's still going to be 0, right? 62 is 60, 10 to the second, to the first power, because 6 times 10, right? 6 times 10 to the first, and we skip that second, right? We can write 0 times 10 to the second if you want. And plus 2 times 10 to the 0th. 10 to the 0th is 1, right? That is our rule that we came up with. I'm going to even write it here. X to the 0th is 1 whole. So any number raised to the 0th power is 1 whole. 10 to the 0th is 1 whole. 2 times 1 is 2. Okay, so this is a number written in exponential notation. Okay. All right, so let's take a look at exercise 3. Simplify. 3 to the 5th divided by 3 to the 5th is 3 to the power of 5 minus 5, which is, well, I'm going to finish this, times 5 to the 0th, and 3 to the 0th times 5 to the 0th. Even though we have different bases, we know that any number raised to the 0th power is 1 whole, so I will get 1 times 1, which is 1. Okay. Exercise 4, 7 to the 17th. Exercise 4, 7 to the 17th times 1 over 7 to the 17th. I can put any number on top of 1 and make it a fraction. So 7 to the 17th over 1 times 1 over 7 to the 17th. Any number times 1 is itself, right? So we will get 7 to the 17th over 7 to the 17th. I know that any number over itself is 1 whole. Or I can also write 7 to the power of 17 minus 17 is 7 to the 0th, which is 1 whole. Next one, exercise 5. I have x multiplied by itself. So we have the number with the same base, different exponents. I'm applying the rule that I have that first one and multiplying numbers with the same base. So I'm adding the exponents together. X to the power of 5 plus 0 plus 2. Okay, so I will have equals x. Any number to the 0th power is a 1, right? So it doesn't really matter. I'm going to add 5 and 2, and this is x to the 7th. So even if you look up here, I can have x to the 0th power, and I can just make it a 1, right? It doesn't matter. And I'm going to multiply x to the 5th by x to the 2nd. I'm adding the exponents. Same exact thing. Next one, exercise 6. X times 4 to the 3rd, and the whole thing is to the 0th. So I will get 6, 1 to the power of 1 times the 0, times 4 to the power of 3 times the 0. So I will get 6 to the 0th times 4 to the 0th, which is 1 times 1. Okay? All right, so these are 6 exercises that we did, and the next one is the problem set. So if you have any questions, please let me know, and if you don't, I will talk to you the next one.